Hi, I'm Ross Reichart from Maya Business Systems. Welcome to our November 2017 Spotlight. This month I'll be looking at the Python programming language on multi-value databases. I want to provide an introduction to Python on the multi-value databases. I won't be explaining Python in any detail, and I won't be attempting to teach you Python. There are a lot of resources on the internet to teach you Python, so I won't be doing that. But what I will be trying to do is to explain what can be done with Python as a feature of multi-value databases. And throughout the presentation, I'll be referring to multi-value databases as a group because Python is coming with Universe, Unidata, and D3, which are the major three flavors of multi-value databases provided by Rocket Software. So what is Python? Well, Python is an interpreted, interactive, object-oriented programming language. It's a scripting language a bit like JavaScript, Perl, PHP, and some others. And it's a scripting language in that there is no compile step. Once you start up the interpreter, you can begin entering Python commands and have immediate results through the interpreter. You don't need to compile a program to run it. Python was started off by Guido van Rossum and had its early days back in the early 90s, about 1991. Guido van Rossum started, but Python's really come to prominence in the last 5 years. The name Python actually does come from Monty Python. At the time that Guido van Rossum was working on the specification for the Python language, he was listening to a lot of Monty Python scripts. He thought he needed a name that was short, unique, and slightly mysterious, and thought that Python fitted the bill beautifully. So, Python we have. Why would you use Python? Well, Python is powerful and fast. It plays well with others, meaning that you can use it on your same machine with other programming languages, and it won't get in the way of the other programming languages. It runs everywhere, and having it on our multi-value databases is an example of that. In another job also, I worked with a company that sold networking equipment, switches and routers and equipment like that. And some of those products also had Python built into them for the same sort of reason, in that it extended the capabilities and the functionality of those products. So Python is being used in a number of scenarios, not just on desktop computers, but in other products such as our multi-value databases. It's friendly and easy to learn, and that's by design. Guido van Rossum was quite influenced by that. He wanted Python to be an easy language to learn and use. And it's open, which means that it has a very open licensing model which encourages the use of Python in many places, and we are seeing that. And these points come from the official Python website, python.org, under the About section. Python's very popular. It's currently 4th on the list of most popular languages according to the TOBE index. TOBE.com aggregates searches on programming languages from the major search engines around the world and compile from those aggregations an index indicating which are the most popular programming languages in use. The index is updated every month, and as of November 2017, Python appears as number 4 on the list. It's 4th behind Java, C, and C++, and just ahead of C#, which is in 5th position. And then the other languages, JavaScript, PHP, and some other languages fall in behind that. In the last month, Python has displaced C# to move into 4th, pushing C# down to 5th position. So it is on the rise, and we can see that from the graph on the right-hand side of this slide. This graph comes from Stack Overflow, which is a similar concept in that Stack Overflow takes statistical analysis of the number of questions being asked about the various programming languages on the Stack Overflow website. And we can see here that Python, which is the thick red line on the graph, is on a steep rise. Some of the other languages are remaining relatively static, and there's a couple in C# and PHP which are dropping off somewhat, but Python is continuing a steady and strong rise in its popularity. Python's taught in universities, so there are many young developers who know Python, and I know that certainly in the science faculties, my son works in science in universities, and he's been writing Python code for a number of years. So it's in wide use in the universities, and there are many young developers who know Python. It has a very active community. If you need to ask questions about Python, there's a subreddit on reddit.com. Stack Overflow has a very active section on Python, and there are very many blogs, tutorials, books, and all sorts of other resources provided by the Python community. It's also a very extensible language, and there's a huge range of available packages to extend and enhance the functionality of Python. These are stored on what's known as the PyPy, or the Python Package Index, and these extending packages are largely supplied by the active community. One of the reasons that Rocket Software decided to put the Python programming language on multi-value databases is specifically to attract new developers. New developers don't want to use BASIC or other procedural languages. They come through their teachings, their trainings, having learned object-oriented languages, and don't want to go back to using an older style of language such as a procedural language. So Python fits the bill. It's popular, it's object-oriented, it's easy to learn, and it's now available on multi-value databases. So which of those multi-value platforms can we get it on? Well, currently Python is available for Universe at the 11.3.1 release on Linux and Windows. It's currently available on Unidata at the 8.2.0 release on Windows and Linux. It's under consideration for some of the other operating systems for those two databases, and it's coming to D3 next year. D3 10.3.1 will have Python added to it, and the beta program for D3 10.3.1 will be beginning early in the new year. So we can expect that probably halfway through next year, or certainly by the end of next year, Python will be available on D3 as well. The current version of Python on the multi-value platforms is 3.4. The current release of Python available on the Python website is 3.6.3. So we're a little bit behind the current release of Python, but not by too much. And I think we can expect that as Rocket continues the development of the multi-value platforms, it will keep increasing the available release level of Python on those databases. Python is a no-cost additional feature to the multi-value platform. It's an optional installation, which means that you don't need to install it on your multi-value platform if you don't think you'll use it, but certainly you can install it and use it. It must be licensed to run. If you don't enable Python on your license, Python won't run, or you won't get connectivity to the multi-value databases. So it must be licensed, which just means that when you order your license, either from MBS or from your reseller, you just need to let us know that you want Python available on the license, and we can make that happen. There's no charge for it, but it must be licensed or it won't run. Python is installed under the Python directory in UDT Home for Unidata or UV Home for Universe. And it is bidirectional, which means that a Python program running from an operating system command prompt can reach into the multi-value database and read and write data from that database. Conversely, Python programs can be called from within the multi-value environment. So from TCL, we can run a Python program, or from multi-value basic, we can call Python programs Python functions to enhance the capability of our multi-value platform. And I'll show examples of both of those shortly. So how to invoke Python? Well, from both the TCL prompt or an operating system command prompt, the command is the same. We simply type Python, press return, and we'll have started up the Python interpreter. And at the bottom of the screen, I've got an example of that. We can see that this has actually been done from TCL on Universe. I type the Python command, press enter, and then we get the Python prompt, which is the word Python with a greater than sign, waiting for some input. So you can see my first piece of input was the command import space sys. Then I pressed return, and I got the prompt back. Then I typed sys.version_info, and that returned to me the version of Python that is running on that platform. We'll see some examples of this soon. If we're in the multi-value platform and we want to run Python commands, we have the runpy command. And the syntax of that is simply runpy space the file name where the Python program is stored, and then the name of the Python program. So a simple example is runpy space pp space greeting.py, and we'll see that program run shortly. Python on the multi-value platform also extends the capability of multi-value basic, and there's an API that allows us to call functions, Python functions from multi-value basic. And we'll see an example of that a bit later on. So I won't dwell deeply on this API, but there are a few calls and we'll run through them quickly. So the pycall function allows you to just execute a callable Python object that has been set up previously in your multi-value basic code. The PyCall function allows you to call and run a function that lives inside of a Python module. Now, a Python module is just simply a block of code with one or more functions in it that are logically grouped together, generally used for code reuse. So the PyCall function allows us to nominate which module we want to use and which function in that module we want to call, and I do have an example of that a bit later on. The PyCall method allows us to call a method on a Python object. The Python get attribute and PySet attribute allows you to get or set values of attributes on the Python object, and PyImport simply allows us to import a Python module into our multi-value basic code, and therefore from there we can start to run functions from that module. So these 6 calls here that we've just gone through extend the multi-value basic to allow us to use the Python language from multi-value basic, and I do have an example of that coming up. From the other side, if we were running a Python program initiated from the operating system command prompt and we want that program to connect into our database and do some work on our database, we have what's known as the U2Py extension module. Now, the U2Py extension module extends the capability of the Python language to connect and use some of the resources of the multi-value platform. Some things it can do are things such as call basic subroutines, run TCL commands, open multi-value files, and more than that. U2Py actually uses a modified UniObjects API to communicate with U2. Okay, let's look at some basic operations now, and the first thing we need to know is how to invoke Python. So I'll bring up a command prompt. I've got one open down here. I'll just put it onto this top window. Okay, so I'm running on Windows. Here's my Windows operating system command prompt, and to invoke the Python command interpreter, I just use the Python command. So I run Python, and there we are. The triple greater than arrow prompt there shows me that I'm in the Python command interpreter. From there, I can just start typing commands. As we said, there's no compile phase with Python. It's just once the interpreter is open, you can start running the program or running Python. So I've got a simple line here that's going to assign the result of 2 multiplied by 3 to the variable x. Now, in Python, we don't have to define variables before we use them. So this is quite legal Python code. So I've now assigned hopefully the value of 6 to the variable x, and I can see the value of x by doing print x, and there it is. I can do something like 2 to the power of 3 into x, print x, and it should read 8, and there it is. Let's assume that I want to look at a string, so I'll put in the string hello there with a new line in between the 2 words. That's what the \n is. So when I print this out, this should show hello and there on 2 different lines. So let's print it out and see what happens. And then we have hello and there on 2 different lines. Python also has quite a nice way of doing substrings. So I can do, for example, slice off just the first 5 characters of that MSG string, print that out, and I get the word hello. So it's interactive, there's no compile phase, we can run these things just from the Python command interpreter. And when I'm done, quit command will get me back to the operating system prompt. If I want to do the same sort of function from TCL, I've got a universe TCL prompt running here. If I want to start Python, I just use the Python command, run that, and here we have Python command interpreter running, and we can see that the prompt is a little bit different. It's for the word Python with the greater than symbol, but the result is the same. So I can do x equals 2 multiplied by 3, print x, 6. Or that example I had earlier on, import space sys, and then do sys.version_info, and it outputs for me the version of Python that I'm running on this machine. Okay, so the next thing we might want to do is run a Python program from TCL. And for that, as we saw before, we use the run py command. Now, before we run this command, let me show the program to you. I've got a simple program, two-line program here called greeting.py. Now, greeting.py is very simple. It takes an input, it asks you what your name is, takes that input, assigns that to the hello name variable, and that's in line 1. So we've got an input function there that will output the prompt to type your name. When you type your name in, the input function will assign whatever you type into the hello underscore name variable, and then the second line down, the second active line, actually the third line of the program, will print the word hello followed by your name. Very straightforward program. So first of all, let's run that from our command prompt because we can do that. Yeah. So if we do Python pp /greeting, greeting.py, it will ask me for my name, Ross. Press enter and hello Ross, there it is. Now this works because the greeting.py program is stored in, actually stored in my Universe PP file, but because that's a text-based file, it's the actual Py code is in a text file and therefore is able to be run directly from the operating system using the Python command interpreter. I can also run it from within from MV Basic. From within the multi-value environment. I'm back at a TCL prompt now, and I can run it with the runpy command. So runpy space, the name of the file where the program lives, and then the name of the program. Type your name, Ross. Hello, Ross. So there's the exact same program run from the operating system, but also run from the multi-value environment using the runpy command. Okay, let's look at a slightly more involved example now. Now, in this example, what I want to do is take some information from my Universe database and transform it into an HTML file. Now, you're probably all familiar with the hs.sales account on Universe. That's got some demonstration data for some customers and products that the customers have ordered. So let's look at one of those records. I've got it on my Universe system here. I've actually made that data available from my Ross account. So if I do list customers 2, customer 2. So there's the output of customer number 2, Diana Morris. She works for the Fast Copy Centre, 431 3rd Avenue. So there's that simple record from the customer file. Now what I want to do is take that as XML data and using a technology known as XSLT, transform it into an HTML file. Now I won't go into details on XSLT, it's an involved technology, but it's suffice for me to say now that what it does is it allows you to specify a template and then apply a block of XML data to that template, and the XSLT technology, according to the rules in the template, will transform your XML data into whatever format you've specified. In this case, I'm saying I want it transformed into an HTML file. Let's just put the multi-value platform on hold for a moment and have a look at a couple of files here. These are just test files. I'm going to show how this XSLT technology works in Python. The first one is some simple sample XML data. So Jack's Enterprises, 123 Pacific Highway Pinball, some products down there and so on. It's just a simple sample bit of XML data. The other file is test.xsl, and that is just showing the template that I'm going to use to transform the XML data into a resulting output. And now this is just straight HTML code, and I'm going to transform according to this template to HTML. It's not actually straight HTML code, it's HTML code in the XSL format. So it's got a number of rules in there which will match up against XML data, and the result will be an HTML file. The Python code to run that is in my invoice file here, and you can see it's a very short file. Firstly, XSLT is the functionality of XSLT is available in Python through the LXML library, and you can see that from the top of the file here that I've imported the LXML library into this program. LXML does not come standard with Python. It's a package available on the PyPy, the Python package index, and I've installed it, downloaded it, and installed it from that Python package index. So in my Python program here, we can see that I've got the test.xsl file, that's my template file. I have the test.xml sample data file, and then this line here, transform XML underscore root, is where the actual transformation of the XML data into the HTML file happens. And then simply I'm outputting that file to u2 underscore test.html. So let's see what happens there. So I need to go to the XSLT test folder. There's a Windows Explorer window with that open. Here's my command prompt. And now all I want to do is run Python pp/invoice.py. When I run that, we should see a file appear in the Windows Explorer window. There it is. If I open that file up, it's on another window here, I drag that up, and there's that invoice. Now that's just standard XSLT technology run by Python using some sample XML data. So let's bring multi-value platform back in at this point. Okay, so we've seen the XML that the sample XML I had. I've got another program that's actually going to now interact with the universe. But before I do that, what I want to do is just show a subroutine that I've got here. So if I copy out a subroutine that's in my BP folder, a subroutine called getCustXML, and this is the subroutine that just runs a simple query on the universe database and returns that query in XML using this XML execute. And I can run that by run BP. I actually call it with another program called getCustomer. And I'm going to feed in customer number 2, and there's the block of XML data returned, Diana Morris, Fast Copy Center, as we saw on the record on Universe earlier. Now with Python, what I'll do now is I call that. Here I've got u2py, which is that u2py extension module that comes as part of the multi-value utilization of Python. It then calls a subroutine called getCustomXML. That's that subroutine I just showed. The return of that is a block of XML, which is then applied to a transform, and that happens inside this process transform function. So if we go up to process transform, we can see a line here, transform XML data in. So it's using the LXML library, applying XSLT technology as I did in my sample before. So what's happening here is the Python code will be started from the operating system. It will call in and run a subroutine on Universe. That subroutine will return some data in XML form. Python code will then take that XML, transform it using XSLT technology as supplied by the LXML library, and output that to an HTML file. So let's see if that works. This time I've got to go to my U2 Python folder. That's where the file will be. I'll start up a command prompt here, and I want to do Python pp/customer is the name of the file. If I just run that like that, it's going to prompt me and say you need to put a customer ID in. I'll put customer ID 2 in, and it will run that, and we'll see a file appear here. Here's customer 2. If I open that up and bring the browser up, there's the invoice. Fast Copy Center, Diana Morris, and 3 products as they were in the record. So that's my first example. That example is just showing creating an HTML file using XSLT technology to transform a block of XML data which has been returned from the Universe database. So that's an example of using Python to extend the functionality of Universe to create an HTML file, and we can go further than that. Python does also have similar libraries that can write PDF files, and you could therefore do something similar but create PDF files using the Python language. So that's just one example of how to use Python to extend the functionality of Universe. For my second example, I'm going to show how we can use Python to extend the functionality of multi-value basic. What we're going to do is call a web service that will return information about the stock trading details of a company on the Australian Stock Exchange. So multi-value basic will call a Python function using the PyCall function that we spoke of earlier. That's one of the APIs that extends multi-value basic for the Python-enabled platforms. The Python module that we call will use the URL libpython module to call a web service. The web service will return details about the stock trading details of the company we request. We'll return that data in JSON format. Python program will then pass that into what's known as a Python dictionary object, and that dictionary object will then be sorted through by Python. Will pull some data out and will create a multi-value dynamic array string to pass back into a multi-value basic program, and we'll display some results at TCL. So first of all, let's look at the web service that we're using. And here's the web service here. I can just run that again. If I refresh that, we've got data returned in JSON format. This is data for the Commonwealth Bank of Australia. We can see that down here. And the current price of the shares for Commonwealth Bank are $80.57. So there's quite a lot of data returned in JSON format by the web service. When we call this from Python, all that data will be returned to Python and it will be passed into the Python dictionary object. We'll then extract some of that data from that dictionary object into a second smaller dictionary object, and then we'll go through that dictionary object, take some of that data out of it, and turn it into a multi-value dynamic array string to return it back to multi-value basic. So let's look at the Python code for that now. I'll bring up my text editor here. Got to look in the ROS account, and in the ROS account there are two functions. I've got the get stock details function and the stock info array function. Now the major one of this is the get stock details function. That's the one that calls the URL, calls the web service, and here's the URL here. When the web service returns, it returns the data into this raw variable. That's then turned from JSON into a dictionary item. That's what JSON.loads does. It takes the raw JSON data and turns it into a dictionary item. We then go through and take some of the data out of that dictionary item and put it into another dictionary item called stock details, and then we return stock details. So what we're returning from this function is a dictionary object, a Python dictionary object, with some of the details of the company that was returned from the web service. Now, multi-value basic cannot deal with Python objects like dictionary objects. It doesn't know what they are, so if you try and work with them in multi-value basic, you'll get an error. So what I then do is take that dictionary item returned from the get stock details function, and I pass it back into this second function, the stock info array function, and all that does is just take a few bits of information from the dictionary object that was passed into it, and it creates a multi-value dynamic array string and returns that back to multi-value basic. So let's now look at our multi-value basic code. If I look at my multi-value basic code here, and here it is. It's quite simple actually. So I'm outputting a prompt to ask for the 3-character stock ticker for the company on the Australian Stock Exchange. I input that, and then I use PyCall function to pass that code ticker into the get stock details function. And you can see that I've used some variables here, module name and get stock details name, which is set up the top. So the module name is ROS_account, which is that ROS_account.py file we were looking at a moment ago. Get stock details is the get stock details function. So this first PyCall function call here will call that get stock details function and pass in the code ticker to it, or the stock ticker to it. That will return the dictionary object, the Python dictionary object, into stock_obj. Now, as I said, multi-value basic can't deal with Python objects like dictionary objects. So what I do immediately there is pass that variable straight back into the next call, which calls the stock info array function, passing in the Python dictionary object, and that stock info array function will go through and pull out some details out of the dictionary item, the dictionary object, and build up a multi-value dynamic array string and return that into stock_details. And from there, it's a simple matter of working with that as with any other multi-value dynamic array string. We then go through that dynamic array, pull some data out, and create an output at TCL. So let's see it run. If I run my stock code program here, the first thing it does is asks me for a stock code. So if I go CBA, it tells me it's the Commonwealth Bank of Australia. We're trading in Australian dollars. The currency is Australian dollars. The current value is $80.57, which you saw before, and that's actually down for today by 31 cents. It's asking me then for another stock ticker code, so we'll compare with Westpac Banking Corporation. So there we are, Westpac Banking Corporation. It's also trading in Australian dollars. Current price is $31.51, and it's down by 10 cents for today. Call up another one, Argosy Minerals, and there's the same results for Argosy Minerals. Now, every time I do this, put a stock ticker code in, it's running the whole process. Multi-value basic is calling the Python function. The Python function is calling the web service. Web services returns. The Python function turns that JSON data into dictionary objects. Then we go through, pull out some of the data out of the dictionary objects, create a multi-value dynamic array string, pass it back to multi-value basic, which then composes this output and gives it to us at TCL. So just finally one more, CSR, and there's the value for CSR. So you can see every time I do this, that's all happening in real time. So it's actually quite quick. It's responding quite quickly to me. When I'm done, I just press enter there, and I'm returned to the TCL prompt. Okay, for my next example, I'm going to show how we can link one data source to multi-value using Python. And my data source I'm going to use, for example, here is SQL Server. So let's first of all look at SQL Server. I've got a program here called Heidi SQL. Heidi SQL allows me to connect to SQL Server and just see what's in the database. So I'll run a quick query here, and we can see that we've got 3,000 records in a sales file on SQL Server. And what we're going to do in this sample here is we're going to transfer data from the SQL Server. We're going to read data from that server and write it to multi-value. We'll be connecting to SQL Server using ODBC, and we'll be also using ODBC to run an SQL query and read the data from it back into Python. And then once we're in Python, we will go through, take the SQL data, or the data that's returned from SQL, and write that into multi-value, in this case universe, using the U2Py extension module. So we've seen already that we've got 3,000 records in our sales database on SQL Server. If I list my sales file here on Universe, I have no records in it. Before we run it, we'll look at the load SQL file, which is the Python program that will be run. So the first thing I do is connect to my sales file on the multi-value platform on Universe. I then connect to my ODBC data source using the PyODBC library, which is another one of these extension packages available on the Python package index and the PyPy. So I use PyODBC to connect to my ODBC data source. I then use PyODBC to run an SQL query, and that returns a number of records off that ODBC data source. And then I just run a simple while loop, looping around, returning one record from that selection at a time. And for every record, I have the record in the sale variable. I create a rec variable, which is actually a dynamic array, a multi-value dynamic array. And the next 6 lines are taking bits of information from the record returned from SQL, take a piece of information out, and insert it into my dynamic array in different attribute positions. So I'm putting the name into attribute 1. I'm doing a little bit of transforming on the date and putting that into attribute 2, the region into attribute 3, product into attribute 4, quantity into attribute 5, and unit price into attribute 6. When I build up that dynamic array object in Python, I file that on my MBS sales object, which is my sales file on Universe, using the same ID that came from SQL Server, and then I loop around and do it again. When we get to when we process the final record, we drop down the bottom, drop out of the while loop, down the bottom, and print a message. Simply say done and show me how many records were processed. So let's see that run. I'll bring up my my command prompt here, and we'll go Python pp /load SQL Py. I run that, and it will return in a moment and say I'm done. It's transferred 3,000 records. So we saw originally in the Heidi program, we had 3,000 records. There was previously no records in the sales file. If I now list sales, I've got data there. If I count the sales file, we can see we've got 3,000 records. If I do something like select sales with name like Ralph, I get 581 records. If I go back to my Heidi SQL program and I do a similar thing here, select start from sales where name like Ralph, and I run that query, we can see that we've got 581 rows. So we're working with the same data set. We have the exact same data in SQL Server, and we now have it in Universe. So it's not the one data source, it's two data sources, but they have the exact same data set in it. So that's an example of using Python to extend or to connect one data source to multi-value and pull data across from that data source and write it into our multi-value database. Of course, we can transform some of that data along the way, as I did with the date. I was just changing the dates from year, month, day to day, month, year format. You could turn it into, do a calculation on it and turn the dates into internal multi-value date format as you transformed it, or you could do other transformations. You could also take data from the multi-value platform and write it into the SQL Server or your ODBC connected data source. So this is an example of Python extending the capability of multi-value to allow us to interact with other data sources. For my fourth example, I'm going to show a graphical user interface built with Python working against a multi-value platform. This is actually a sample that was written by Rocket Software and comes in the XDemo account that's supplied with the Python-enabled multi-value platforms from Rocket. The sample uses the tkinter graphical display package, which is another one of these packages that extends Python and is available on the Python package index, the PyPy. The data and code for this example are both in the XDemo account, and I won't try and go through the code. It's quite extensive, and Rocket wrote it. I didn't write it. But when we've got your platform set up, I recommend that you go to the XDemo account and have a look at the code to see how they went about it. Now let's see the sample run. I'll bring up my command prompt here. I'm still logged into the directory for the ROS account, so the first thing I've got to do is log into the XDemo account, or the directory for the XDemo account. That's where the code runs. It's also in the PP file here, and because that's a text file on Universe, the program's available to be run outside of the Universe environment. So I run it in the same way when running other programs, PP, and the program is called Members Demo. I round that up, and it will pop up a form here with members info on it. With none of the info filled in except the members ID. So I've got members info ID, members ID number 1566. If I click the member info button here, it will extract the data for member 1566 from Universe and populate the form with that data. If I click the search last name button here, it pops up another little window which lists the IDs of other members that have the same surname. So I can go to member 930 here, choose that member ID, and it pulls up the information for that member and populates the form with their data. I can also do things like add a credit card for that member, and that produces another pop-up. This one's got a drop-down where I can choose what type of credit card, the expiry date, card number, security card, and then I can click the add card detail. So this is just a sample of showing the typical graphical user interface controls that are available with Python, with this tkinter library. It's important to note here that this Python code is running on the Universe database server. We can't build a graphical interface at the moment with Python that uses the U2Py extension module and runs on a machine other than the Universe database server. It needs to run on the same database server to utilize the U2Py extension module to get data out of the multi-value database. However, what we could do is build a graphical user interface that ran on a different client machine and consumed web services supplied by the multi-value database and use those web services as the data connector. And that way we can build a client-server architecture with the graphical user interface running on a client machine and connecting via web services. We can also run Python in a web server. So we could build up a web application with Python running on a web server, and that could communicate either using the U2Py extension module if it was on the same machine as the database server, or perhaps using a web service to communicate with the multi-value database if the web server was a different machine. But the point I'm getting to here is now that we've got this modern, object-oriented, interpreted, popular language that young developers like to use, this language called Python, that's now available on our database server, and it can be available on a web server and a client machine for a client server architecture. So we have this modern language called Python available on multiple tiers of our application. So I think that this is a fantastically exciting thing that Rocket has done by providing this modern language to us to extend our multi-value applications, not just the functionality, but to extend the appeal of them to more modern developers. So I recommend that you investigate more deeply what Python can do on multi-value. So before I close, just a short page of a few useful links. The first one, that first link should read www.python.org, not www.python.org, but www.python.org, and that's the official Python site. I recommend you start there. That's got some great information, some documentation on it, a history of the language. It's got some tutorials on getting started on Python. It's got a link to the Python package index. There's a great deal of information on that site, so I recommend you have a look at there. The next three links are links to the Rocket Software blog site. And if you haven't been to the Rocket Software blog site, I also recommend you go there. They blog regularly, not just on Python on multi-value, but all aspects of multi-value platforms and other Rocket products. So spend some time on the Rocket Software blog site if you haven't. But these three links that I've shown here, the second, third, and fourth links on the list, are three parts of a three-part article written by Mike Rajowski, who is one of the senior Rocket engineers involved with the Python on multi-value platform. And Mike's written these three articles to help people get started with Python on the multi-value platforms. The fifth link down is a link to a PDF file, which is their U2 Python lab. So they allow you to download that and some code to help you set up a lab environment where you can run through some exercises to help you get set up and running with Python on U2. And the final link is a link to the Stack Overflow article that I referred to before. That I showed that Stack Overflow graph showing the increasing popularity of the Python language. That graph came from this article, and the article is talking about the incredible growth of the Python language. So I'm Ross Reichart. My email address is there on the screen. If you have any questions, or if you have any use cases, or you'd like to start a discussion with me about Python on multi-value, I'd love to talk to you. So my email address is there. Please feel free to call me or send me an email at least, and I'd love to hear from you, hear what suggestions you might have. So thanks for your time. I hope you've enjoyed this, and if I can help you in any way, please send me an email and let me know. Thank you, and bye for now.